Let's look at the resolution of forces. If there are more than 3 forces acting on a body, we can't use trigonometry because we can't make a triangle to solve the problem. Therefore, we need to resolve each force into its I and J components. And that's if they're acting in the same plane. So for a particle that is in equilibrium, if all the forces acting on the particle are resolved into their I and J components, then the sum of the I components has to be 0 and the sum of the J components is 0. And that's when the particle is in equilibrium. Okay, so in regards to resolving a force into its X or its I and J component, or its X and Y component. So looking at our diagram, here is our vector. To resolve it into its X component or its I component, remembering that X is cos theta and Y is sine theta. Now you don't have to remember that. If you remember that this is the magnitude of F, which is pretty straightforward, you can use trig, your right angles here, so that's your hypotenuse, your opposite and your adjacent. So you can see that H and A, which is for the X component, is cos, or O and H, which is for my Y component, is sine. You can look on your formula sheet and you'll see this kind of there for complex numbers. So as we move through the curriculum this year, this will start to click a little bit better.